Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today, in the subject of chemistry, in stoichiometry, Unit 4.2, we will be talking about conversions with moles and particles. So the prerequisites, if you don't understand scientific notation or haven't watched my video, please watch 4.0 scientific notation, as well as 4.1 dimensional analysis, where we go over how to do conversions. Now, only one thing you really have to understand before we get into the conversions is what is a mole. Well, just how a pair of shoes is 2 shoes or 1 dozen of eggs is 12 eggs, a mole of something is 6.022 times 10 to the 23rd of that thing. Now, you're saying, why such a large number, such a very specific number? Because, well, with atoms are so tiny, millions and millions and billions, just in something small like your phone. There are billions of atoms. So we need a way to classify them as without going into extremely big numbers. So we have 1 mole. And 6.02 times 10 to the 23rd, because that is Avogadro's number. Some time ago, a guy named Avogadro, who was like a scientist, a chemist, saw that proclaimed that there should be 6.02 times 10 to the 23rd atoms in 1 mole. So when someone says a mole of something, you just know that's 6.02 times 10 to the 23rd atoms. So we use moles a lot because it's just a simpler way than atoms and molecules. But it can also be 6.02 times 10 to the 23rd anything. It doesn't have to be atoms. It can also be molecules or something else. Now let's go here. So example 1. Think about a stylus. That's a pencil. Sorry, low light in here. If you don't have a stylus, I recommend you get one already so you can draw on screens for this. Example 1. You have 7.2 moles of carbon. Let's underline. We underline are given 7.2 moles of carbon. How many atoms of carbon do you have? Box what you're trying to get. So we see 7.2 moles of carbon. So that's what we have. We have to get that to atoms of carbon. Now we know a mole of carbon is just 6.02 times 10 to the 23rd atoms. So that's all we have to multiply by. 0.02 times 10 to the 23rd. Make this a little longer. Atoms. Really bad. Let me go erase that really quickly. Atoms of carbon per, you have to always remember, per 1 mole of carbon. So it seems like we're finished. If we got this, we'd get to atoms of carbon. Let's just check this will work. We cross out moles of carbon and cross out moles of carbon, and it equals some amount atoms of carbon. But let's do our calculation. So we can go to calculator. So we know that we have 7.2 times 6.02 times 10 to the 23rd, but we're not going to include that in our calculations with numbers, because if you're multiplying something by 10 to the 23rd power, then we know the 20 times 10 to the 23rd power, it carries over. So that's the same thing as 43.344 times 10 to the 23rd power. But we know when using scientific notation, it has to be between 1 and 10. So we move this 1 to the left to get 4.3344. But when you move it 1 to the left, that makes the number 10, like up to 1 power of 10 smaller. So when you move it to the left 1, you have to increase the power you have to increase it 1. So instead of times 10 to the 23rd, you do times 10 plus to the 23rd plus 1, which is times 10 to the 24th. So if we move it over, we'll simplify that, round it to the nearest hundredth. We get 4.33 times 10 to the 24th atoms of carbon, and box your answer. And there we go. Now let's move on to a different problem. You are given, we already underlined that, 5.964 molecules of CH4. How many moles of CH4 do you have? So first off, we write our given, that's a bad 5, not 5.964 times, this is a long one, times 10 to the 24th we just write molic instead of molecules. Mock of CH4. Okay, so we want to know how many moles. So if we want to know how many moles in a certain molecule, we have to multiply by, moles per molecule, because it's saying how many moles is this. So we have to find a way to convert to moles. So if we want to convert to moles, we know we have to multiply moles over molecules to cancel out, because we have molecules, moles per molecule gets moles. So we go over a little bit, and we do times 1 mole of CH4, which is just the same as 6.022. Actually, not 2, well, it's 2, but we just use 6.02 times 10 to the 23rd. Molecules of CH4. Now we know we have to get moles of CH4, so we'll just put that as our final answer. Equals moles of CH4. So as usual, we don't include the 24th, we just do our numbers. So we'll do 5.964 over 6.02. And as we know, the times 10 to the 23rd count goes over. It transfers over. So we have 0.9906 times 10 to the 24th. But uh-oh, that's not between 0 and 1. So you have to move it 1 to the right. And when you move it 1 to the right, you don't add to the power, you subtract it for every time. So you have to move over 1. So that means that you subtract 1 from the power. So instead of 0.9906, we have 9.906. Instead of 24, we have 23. So our final answer is 9.906 times 10 to the 23rd. It's 9, wrong side, 9.906 times 10 to the 23rd. Or no, it doesn't cancel over, it's my bad. We did 24 over 23. So we get 0.9906 times 10 to the first power. So we had to move over 1, so we subtract 1 from that power. So we get to the 0th power. My fault, because when you are dividing exponents like we are here, always remember to box your answer. Because you always do calculations with the numbers in front, and then you do calculations and you take into account the powers. Because when you divide with dimensional analysis, is you divide the top by the bottom. All you have to do is subtract. So when you are multiplying two exponents, you add them if they have the same base, and when you're dividing, you subtract. So they have the same base, which is 10. So 10 to the 24th over 10 to the 23rd is just 1, because 24 over 24 minus 23 is 1. But if you are multiplying them, you just add. So if you do 10 to the 24th times 10 to the 23rd, that's just 10 to the 47th. Now let's go down here and do a hard one. Do a bonus problem. I think you guys are ready. I don't know if you do, but I think you guys are. So how many atoms of hydrogen, are in 5.67 moles of CH4? So it gives us are wanted and are given. So first, of course, we start off with 5.67 moles of CH4. 5.67 moles CH4. Now, we can't have atoms of CH4, but we can have molecules of CH4. And we know we can convert from moles to molecules. So we know we just use Avogadro's number to convert from moles to molecules. So we do over 0.02 times 10 to the 23rd molecules. We have moles. When you're doing moles, when you have moles, you multiply by Avogadro's number to get an atom or a molecule amount. But when you start off with like an atom amount or a molecule amount, you divide by Avogadro's number. So here we have, on the bottom, we have 1 mole CH4. Once you start doing dimensional analysis for a while, you start to kind of know what has to go on the bottom, because the top and the bottom have to cancel out except for what is wanted. So you always have to map out, what are we converting? What are our steps? What has to cancel out? What are these numbers? So you can start to do all that. 6.00. It's a bad decimal. Let's just rewrite that. 0.02 times 10 to the 23rd molecules CH4. Now we have to think, when you're doing dimensional analysis, well, what do we have now? What do we have to keep going? What do we have to do to get atoms? Well, right now, we know we have molecules of CH4, because the moles of CH4 cancel out, but we need atoms of hydrogen. So here it just uses a little bit of thinking. Well, one molecule of CH4 has 1 C and 4 H's. So there's 1 atom of carbon per molecule of CH4 and 4 atoms of hydrogen. So we have to multiply by 4 atoms of hydrogen per 1 molecule of CH4. And let's check, do this stuff all cancel out? Well, moles of CH4 cancels with moles of CH4. Molecules of CH4 cancels with molecules of CH4. And we're left with atoms of hydrogen, which is exactly what we wanted. So let's go over. We can start writing before we do our calculations. We know we get something that equals, we get atoms of hydrogen. Now, let's calculate to find out exactly how many we have. So we know we do 5.67 times 6.02 on top, and times, it's over here, 4 times multiply by 4. And we don't have to divide by anything, so we're just left with 136.5336. But remember, the times 10 to the 23rd transfers over. But 136 is not between 1 and 10, so you have to move it over to the left twice. When you move to the left, you increase. When you have to move to the left, you increase the exponent. When you have to move to the right, you decrease it. We have to move to the left twice, which is 2, so we increase it by 2. 23 plus 2 is 25. When we move it over twice, we're left with 1.36. So our final answer is going to be 1.36. 23 plus 2 is times 10 to the 25th power atoms of hydrogen. Let's just pretend that area is closer. So, yeah. Thanks, guys. Please share, like, subscribe, and turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comment section below. Thank you to my chemistry teacher, Dr. B, for teaching me all this information. Please join us next time where we talk about moles and grams. Thank you guys. Goodbye. And always remember, knowledge is power.